Go over this worksheet on factoring. Okay, so factoring is such a critical skill for the rest of this year. So we learned some harder factoring now, the AC method, but we always want to look for a GCF, and that's how we're going to start number one. So with number one, there's only two terms, and all we can do is factor out the greatest common factor. So always look for a GCF. Greatest common factor is a 4 when you look at the numbers. So I know a 4 fits in a 4, 4 fits in a 12. Okay, 2 is a common factor, you want the greatest. And then you also have an x squared in common. So that goes on the outside. And then all you have to do is basically divide each of these by 4x squared, or think 4x squared times what is 4x cubed. You're just going to have an x inside. And then this needs to be a 3. Okay, so it's just checked by the distributed property. You multiply it, you're back to the original problem. Okay, so now this one, we do not have a common factor other than 1. So that's the game that we have to play. We need to do the AC method. So I'm going to start by taking my A times my C that goes up top. So I need a 45B squared. This middle term, you go in the bottom. Okay, that's how we're going to start the AC method. And then our job is to come up with ways of getting 45. My brain already knows it. That will add up to 46. We would need a 45V and a 1V. Okay, so now again, you could use a box. You could use a box. I prefer this method. It's a little bit more streamlined, plus there's a built-in check. So 9V, so I'm going to rewrite this with, replace the middle term with 45V and a 1V. It's still a 46V, but it's going to allow us to find our factors. So I'm just going to quickly rewrite this, and then we split it down the middle. We look at the two terms on the left, take out the GCF. So in this case, we know 9V fits into both. So we're left with V plus 5. Okay, if you distribute the 9V, you're back to the 9V squared plus 45V. And on this side, you factor out a 1. And here's why I like this method. What's in parentheses, you're going to see on both sides. Okay, you have to. So here's your factors. 9V and the positive 1. So what's on the outside makes up one of your factors. What's in common is your other factor. Okay, and it's always a good idea to check by FOIL. 9V times V, there's your 9V squared. Outers is a 45V. Inside, the 1 times V is a 1V. We know together it adds up to 46. We found that in the beginning. And then 1 times 5 is a 5. Okay, same thing here. There's nothing in common other than a 1. So I'm going to write 90R squared, 23R. And then I'm just going to think of ways of getting 90. Okay, so again, lots of different techniques, a lot of different things. I like to just think of starting with 1. I know 1 and 90, okay, but I can't get a 23 out of that. 2 and 45, 3 and 30. Okay, still can't get a 23. So then I'm going to try to see 4 doesn't work, but 5 will. So 90 divided by 5 is going to be an 18, and then hopefully you realize that also adds up to 23. Okay, so that may take a while to find it, but it's there. Okay, I'm not going to give you a problem where you're wasting your time and it can't be factored. So these can all be factored. So it's just a matter of coming up with the correct pieces. Okay, so now I'm just going to rewrite this where I replace the 23. Now, if you have 18 first, that's perfectly fine. I'm going to write the 5R and the 18R plus 10. Okay, still the same as the original, but allows us to basically split this in half. On this side, we can only factor out the R. 9R plus 5 is in parentheses. On this side, we have to factor out a 2. But notice we'll get that 9R plus 5. 2 times 9 is 18. 2 times 5 is 10. So here's your factors. The R and the positive 2, and the 9R plus 5 finished. Okay? Now, this one you could use the AC method, but I need you to also be aware of something you learned in Algebra 1, difference of perfect squares. So if you recognize that you're subtracting perfect squares, then you could be factoring this in a couple seconds. You just basically take the square root. 9x squared is a 3x and 3x. A negative 100 is a positive and minus. And you take the square root of 100, which is 10. Okay? Your outers and inners cancel out. That's why there's not a middle term. So the middle term is really 0. Okay? This next one, nothing in common. Make my x. I take a times c, so a and c will multiply to give you 42 x squared, negative 23x. Okay, so here's where one's going to be positive, one's going to have to be a negative to add up to negative 23. Okay, so again, 42 and 1, that's not going to help us, but I'll write 1 and 42. That can't give me a negative if one's positive, one's a negative. Then you try 2 and 21. That's not going to be able to, because one has to be positive, one has to, they both can't be negative. So if they're both, oh, actually, sorry, they are. They both have to be negative because it's a positive 42. So I'm going to need a negative 2x and a negative 21x. Okay, that gives you the negative 23. There for a second I was thinking that had to, since AC, the product is positive, the signs have to be the same. So in this case, they're both negative. So I'm going to replace the negative 23x with negative 2x and a negative 21x. Split it down the middle, factor out a 2x. Okay, so people mess that up. When you factor out a 2x, if you have a 2x, you're left with a 1. So 2x times 3x is 6x squared. 2x times negative 1 is the negative 2x. And then on this side, you have to factor out a negative, okay? And what fits in is a 7. But you'll feel good because if you divide each of these by negative 7, you get a positive 3x and a negative 1. And that has to happen. The 2x minus 7 is one of your factors. 3x minus 1 is the other. Okay, if you check your outers and inners, it agrees with the values that we found earlier. Okay, this one's all positive, makes it a little bit easier when everything's the same sign. So 20n squared adds up to a 9n, not long to find 5n and 4n. Okay, so I'm going to take this original problem, write it as a 5n plus 4n plus 2. Okay, split it down the middle, 5n, 2n plus 1, factor out a 2, 2n plus 1, final answers, a 5n plus 2, so the pieces that are on the outside, and what's inside the parentheses on both sides makes up your other factor. And again, this was a quiz. Take 2 seconds just to make sure everything agrees with the original. So FOIL, 5n times 2n is 10n squared. Outers, inners add up to the 9n. 2 times 1 is 2. Okay, for number 7, you can see I messed up. So re-record this. It's early. But number 7, you have to take 7 times negative 9, which is going to be negative 63, and I'm going to have an x squared, and I'm going to find the pieces that add up to 18, okay? So again, I like to start with 1 and 63. Can't get an 18 out of that combination. Again, one's going to be positive, one's going to have to be negative. But then 63, you can't divide by 2, but you can divide by 3. And what you're going to see is, as soon as you write 3 and 21, that's the combination we can use. So if I use a positive 21x and a negative 3x, that's going to add up to 18x. So I need to rewrite this problem so that I have a 21x and a negative 3x, and then minus 9. I split it down the middle. I factor out what's in common, which in this case is a 7x. I'm left with x plus 3. On the other side, I have to factor out a negative. So anytime this is negative, you factor out a negative, and then you factor out a negative 3. And what's going to happen, if you divide each of these by negative 3, you have just an x inside and a positive 3. So 7x minus 3 and x plus 3 are your factors. Okay, again, quick little mental check. There's your 21x, there's your negative 3x. It agrees with the 18x. Okay, and then this last one on this page, this one's pretty easy. 2 times 9 is 18, so I'm going to have an 18p squared. Really easy to find the combination that's going to add up to 19. It's going to be 18 and 1p. Okay, so 2p squared plus 18p plus 1p plus 9. I split it down the middle, factor out a 2p on this side, and you're going to see on this side the only thing in common is a 1, so factor out a 1, and then you're left with 2p plus 1 and the p plus 9. Again, think of this as a puzzle. The pieces will fit. It's just a matter of you finding the pieces. Okay, 2 more where you're just factoring. Then we will actually use this to solve equations. Because remember, these are not equations. So you're just simply told to factor, and that's all we can do. In this case, only 2 terms. You can only factor out what's in common. And in this case, it's only a k. So 7k minus 2, and you're done. Okay, that's all you can do to that problem. And then last one where you're just factoring, AC method, make your little diamond or your x, and I multiply, I'm going to get negative 70x squared, and I'm going to find a combination. Oh, that's a v. We'll make it a v. You don't want to mix up the variables. And so it's not going to take too long. My brain already thought of it. I know it's going to be a 35v and a negative 2v. Okay, 35 times negative 2 is the negative 70, but they then add up to 33v. Okay, so I'm going to quickly rewrite this. Again, you can't change the problem. Okay, original problem is the original problem. Has a 33v in the middle, but by breaking it up, it allows us to find the pieces. Okay, so 7v is the GCF on that side. V plus 5 is what's going to be inside the parentheses. You go over here, you factor out your negative 2. V plus 5 is in parentheses. And just like that, we factored correctly. Okay? The second part, we are supposed to solve, and reminding you, you must have 0. Okay, so always look for a GCF. There's nothing in common with number 11. So we're ready to try to factor this so that we can see the answers. In this form, standard form, I have no idea what the solutions are. But if we factor it, then I can tell you the answers. So the first thing we're going to do is take 7 times negative 24. That's going to be a negative 168. Okay, and it's n squared. And I'm not going to give up until I find the combination that can add up to a 53. Okay, so we have 1 and 168. 168 divided by 2 is going to be 2 and 84. Doesn't work. 168 divided by 3 is a 56. And just like that, your brain should be thinking, hey, if the 56 is positive, and then the 3 is a negative, it's going to equal the 53n. Okay, that's the game we have to play. You can get good at this. You can get quick and efficient. And once I split this down the middle, I factor out what's in common. You should know that 7 fits into 56, so you can factor out a 7n. n plus 8 is in the parentheses. If I factor out a negative 3, I will see that n plus 8 on the other side. 7n minus 3 and an n plus 8 equals 0. Okay, so now we'll start with the easy answer. Easy answer is just a -8. So you look at this factor, what turns this into 0, again, whole idea of this is the zero product property. Anything times 0 is 0. So if I can make this factor 0 by replacing the n with a -8, I have a solution. Where the other one, though, it's going to be a fraction because I have to add a 3 and divide by 7. Okay, and again, if you can't do that in your head, off to the side, you will set your factor equal to 0 and solve. Okay, two-step equations that you did a long time ago. There's where your 3/7 is coming from. Okay, so hopefully you'll get good at those. And then this one, good news, everything's positive, so it makes it a little bit easier, I think. It's the ones that are negative that some students struggle with. But 4 times 15 is going to be 60, and we're not going to give up until we find a combination of 60 that adds up to a 17. My brain already thought of it, but you would go through your 1 and 60, that doesn't work. 2 and 30 doesn't work. 3 and 20, that's not, because again, don't let your brain trick you and say, well, if I use a positive 20 and a -3, we need the signs to be the same since it's a positive 60 as a product. So 3 and 20 won't work. 4 and 15 won't work. But the good news is 5 fits into 60 12 times, and that will add up to 17. Okay, so again, you have to be good with your numbers. Okay, good number sense to get good at factoring. Okay, so it's going to take some practice, but try to come up with a system that's going to work for you to find the factors. Okay, so I split it down the middle. I factor out my GCF, which in this case is just an n. I will have 4n plus 5 on that side. Then on this side, I must factor out a 3. But the good news is when I factor out a 3, I see the 4n plus 5. I know I didn't make a mistake. N plus 3, 4n plus 5 equals 0. -3 is the solution, and -5/4. Okay, so again, I can do those very quickly. The second you show me the factors, I know the solutions. Okay, so you'll get good at that. Look at the factors, and you should be able to tell me the solutions. Okay, a couple more. This is going to be a -36n squared, -16n. Again, one has to be positive, one has to be negative. So 1 and 36 won't work. 2 and 18, though, can work. So if I have the -18 and a +2, that's going to add up to the -16 that I need. So 3n squared minus 18n plus 2n minus 12 equals 0. Again, we're not changing the original problem, okay? We're using a technique to help us find the factors. I factor out the GCF. I see we're left with n minus 6 in parentheses. I must have that n minus 6 in parentheses on the other side. And the good news is if I factor out a 2, 2 times n, there's the 2n, and then 2 times -6 is -12. So 3n plus 2 and an n minus 6 equals 0. +6 is going to be an answer, and -2/3 is going to be an answer. Okay, so again, got to take some practice. Hopefully you're starting to be able to do these on your own. Okay, so here 7 times 4, we will find a combination that can add up to a -11, and my brain knew, again, I'm not going to go through the list here, I know -7x and a -4x. -7 times -4 is 28, adds up to -11. I'm going to go through this very quickly. Again, the order doesn't matter how you put these terms, okay? So I split it down the middle, factor out a 7x, x minus 1. Over here I must factor out a -4 to have that x minus 1 in parentheses, 7x minus 4, and x minus 1 1's an answer, 4 over 7 is the other answer. Okay? Now, last couple, not 0. Okay, all the other ones we could start right away by factoring because it was equal to 0. Well, here we have an extra move. You must get this in standard form. Okay, so this must be 0. Must be 0. So 3n squared plus 17n minus 28 equals 0. 3 times 28 is going to be 84. Okay, so there's my diamond, 84n squared, and then 17n. 1 and 84, 2 and 42. 84 divided by 3 is 28. Still can't get a 17 out of those combinations. When I divide by 4, I get 4 and 21. Oh, and this is a negative, so that's going to be, that's what I need, because one has to be positive, one has to be negative. So in this case, a negative 21n and a positive 4n. Okay, so 3n squared, I'll put the minus, oh, I have these backwards, the signs are backwards. I need a positive 21n and a minus 4n. Okay, so again, you can't change the problem. Okay, if that was a negative 17, then the signs would be reversed. But since it's positive, I need positive 21. Split it down the middle, factor out a 3n. Over here, factor out a 4, a negative 4. And I'm going to see I have negative 4 times n. There's a negative 4n. Negative 4 times 7 is negative 28. 3n minus 4 is one of my factors. N plus 7 is my other. So that means negative 7 is an answer. And 4/3. Positive 4/3. Okay. This one, subtract 2. And now we have it in standard form. We make our little diamond. We're going to see that 2 times negative 35 is negative 70 k squared. And we're going to find a combination of two numbers that multiply to give you negative 70, but add up to a negative 9. Okay, so my brain doesn't see it just yet, so I'm going to go through my list. 1 and 70, 2 and 35, 3 doesn't fit, 4 doesn't fit, but 5 does, 5 and 14. And I can get a negative 9 out of that combination. So if it's a negative 14n and a 5n, it adds up. So again, you got to know some number facts for this to work. Okay, so if it's taking some time, just be careful not to miss a combination that could work. So 2k squared minus 14k plus 5k minus 35 equals 0. Split it down the middle. K minus 7, and there's the other side. When I factor out a 5, I know 2k plus 5 and k minus 7. So my answers, once I factor, positive 7 and negative 5/2. Okay, so hopefully you're seeing the picture now. 5p squared minus 18p. I must bring that 3 over by subtracting. You must have 0. Make your diamond. AC is negative 40. P squared, negative 18. P, that time my brain knew it right away. I know it's going to be a negative 20p and a 2p. Okay? So sometimes you can see it right away. Other times you're going to have to spend some time trying to find that combination of numbers. Okay, sometimes you get lucky and you see it right away, other times, but you will be able to find it. So find a method that works for you. So when I factor out my 5p, the GCF on this side, I get a p minus 4 inside. When I factor out the 2, I see the p minus 4. So 5p plus 2. and p minus 4. Our answers are negative 2/5. Okay, so you have to subtract the 2, divide by 5, and then positive 4, the easy one. Okay, last one probably looks the hardest, but it's actually not that difficult. So you add your 7p squared. Always make sure your squared term is positive. Okay, I'm going to subtract the 6. When I clean that up, I'm going to have a 5p squared plus 24p, and then minus 5. This will be very easy to factor, okay, because it's a negative 25p squared that adds up to a 24. So a positive 25p and a negative 1p is the combination we need. So I will quickly replace 25p minus p minus 5 equals 0. Split it down the middle. 5p, p plus 5, negative 1, p plus 5 equals 0, 5p minus 1, and p plus 5 equals 0. So negative 5 and 1/5 will be my answers. Okay, so again, lots to keep in mind when you're factoring, but get good with numbers, okay? That's my suggestion. Thanks for watching. You're going to hand this paper in to me for points. Okay, make sure you're showing all the work too. You can't just write down the answers. You got to show the technique of how to factor. Okay, thanks for watching. Take care.